I'm Greg Lindner. I'm the research director for Croda's crop care and healthcare team here in Newcastle, Delaware, and I've been asked to say a few words about our purpose-designed wind tunnel, which you can see in the background. It represents about 3 years of intense research into finding a way to bring together separate scientific disciplines to provide highly accurate and very precise characterization of agricultural spray quality. What makes it unique is something that we are very proud of. We decided some time ago that we wanted to have the ability to measure, characterize spray quality under a variety of conditions. And in order to do that, in order to use a variety of measurement techniques to capture as much data as possible from each experiment using different techniques, applying different parameters to our experiments, we decided that there's really only one way for us to be able to do that, and that's for us to align our wind tunnel in the same direction as you would normally see with an agricultural spray application conducted from the ground, which is vertical. And that obligated us to make some design choices that give us a very unique functionality and the ability to really dive deeply into the characterization techniques themselves. In addition to being vertically oriented, the system is highly automated, and we decided, after examining the facilities currently operating in the market in a variety of academic and research environments, that we wanted to minimize variation absolutely based on different subtle differences in operating conditions and parameters, different operators. So what we want to make sure is that we have the ability to recall and reproduce these measurements to an extremely high degree of precision. So automation is key. And bringing all those different scientific disciplines together for mechanical engineering and aerodynamics, and agricultural engineering, involved a little bit of translation, which took us a good long time, but in the end we believe was really worth it. It gave us the ability to design and execute experiments that we don't think are really possible anywhere else in any other type of facility designed differently. We have the good fortune to be able to stand on the shoulders of giants in this process, take what's been learned at significant investment of time and expertise and sweat equity to get where we are today, and we're very pleased to be able to share this with you and open the opportunity to discuss what measurements are relevant and how Croda might be able to apply its unique measurement capability to your specific problem.
I'm Logan Dempsey, a technology specialist with Croda Crop Care, and I'm in charge of running the Croda low-speed wind tunnel.
And I'm Elias Brown. I'm Logan's assistant, helping him out with the wind tunnel.
So, the apparatus you see behind us is the recirculating low-speed wind tunnel for Croda Crop Care, designed specifically to characterize agricultural sprays and really study the droplet size distributions from different nozzles. So what you see behind me is the vertically oriented low-speed wind tunnel. If you look at the top, the direction of the wind is to come from actually above the roof, moves down through the spray zone, which is this spray chamber up here. We're equipped with a Hilo Sympatec particle size analyzer to measure droplet size distributions as we spray samples. If we orient you, the wind comes vertically down through the top, and then it sort of makes this turn here and goes out the side and recirculates the wind.
So this part of the wind tunnel is the nozzle setup that we use to test different sprays. At the top we have a 3D printed boom that is aerodynamically designed to not disturb the laminar flow of the wind going to the nozzle. At the bottom we have a quick connect so that we can test a wide variety of nozzles.
So what we have here is the command center for the apparatus. You can see we have two computers available to us. One is used to control the wind tunnel itself, and the other is used to control the Helios laser system. In addition to these computers, we're equipped with video conferencing capabilities so people can dial in and we can do live demonstrations of the wind tunnel as it's in operation. So now I'd like to walk you through what it looks like when the wind tunnel is actually in operation and give you a live demonstration of what happens. Here's the command center of the wind tunnel itself. The first thing we do is, what we have over here is an RFID identifier so we can select which nozzle we're spraying from. Then we can come over here and set what solution we're spraying, what's the wind speed we're interested in looking at, and also what's the pressure behind the nozzle, among other parameters. So just to give you an example of what runs, we're going to run a quick demonstration using no wind speed at all. And you'll see how the nozzle moves through the laser sample user. So the first thing to do is to turn the wind on, and then turn the pressure on the nozzle on. And the nozzle begins to spray and the pressure is equilibrated. Once that pressure has equilibrated behind the nozzle traverses across the wind tunnel into the laminar flow regime of the wind area where we're actually sampling and measuring the droplet size distribution and towards the other end. This ensures we collect the entire droplet size distribution in each experiment that we run.
So here's the data that we just gathered from the run. On the y-axis it shows the volume-weighted density distribution, and on the x it shows the particle size that is graphed logarithmically in microns. From this data we can get a cumulative distribution that can show us the percentage of fines under a certain amount or over a certain size. Thank you for letting us share Crota's wind tunnel capabilities with you.
We look forward to collaborating with you.